Yes, today we are going to discuss about the further topics of the logarithm. So we are starting logarithm here from the law of logarithm today. So that's the first topic for today. The laws of logarithm. Right. Okay. The first law is this is the first law. First law is if you get log the base a x plus logarithm of base a y. Remember that these two bases should be similar. If it is so, you can write this one with log a, the product of these two, xy. Right. That's a way of getting this. Right. The second law, for example, I will get one example for this. That is, if I get log 10, 20 plus log 10, 5. So you can write this one as log 10, how much? Log 10, 20 into 5. That is, you can write this one as log 10, 100. Log 10, 100 is how much? Log 10, 100 is 2. So simply you cannot find log 10, 20 or log 10, 5 manually. But when you do the simplification, you can get into this answer. Other than that, you need the calculator to do this. That's the first rule where we need to learn. The second rule is if you get log ax minus log ay, right? Let's see where you have some, if it is a minus, here remember that always I'm repeating this, the base should be same. Here the base is same, other than that you cannot write it. So you can write this one as log a. If there's a subtraction, you can write it as a division. X over y, x divided by y. That's the second rule. For example, if you get just like this, if you get log 3, we'll get 162 minus log 3, 2. So you know that log 3, 162, you cannot get a direct answer without a calculator. Log 3, 2 also, you cannot get it. But you can do the simplification like this. Log 3, 162 divided by 2. That is turned up to log 3. This is a subtraction. Therefore, it is a division. 81. Log 3, 81, you can find a value. That is one kind of example where we need to understand. So the other side even, you can just get it. The third case is just like this. Log a x to the power y. X to the power y, you can write it as, you can write this power out and you can write it in this way. Log a x. That's way of getting it. Okay, let's go to this one. So this is a third rule where we should learn, right? For example, if you come across with this kind of situation, one example is if you get log 2, we will get 4 to the power 6 or something. For this situation, you can write 6 times of log 2, 4. Then you can say 6 times of log 2, 4 is 2 to the power 2 is 2. So 12. That's the second fact we have to understand, right? Okay. Then the next rule. The fourth rule is if you get log AB, you can write this is similar to 1 over the reciprocal of logarithm. Log BA. Let's see what kind of situations you need this rule. That's a fact where we have to understand, right? For example, if you happen to get this kind of situation, this is a situation where we need to know this rule, right? That is, if you need to get log 8, 2, log 8, 2. We know that that means you need to understand about 2 is 8 to the power what? What is the power of 2 for base 8? But you can, if you just convert it to this form, what do you get with it? Log 2, 8. You can write in this way. Now you can see this is log 8, 2 is finding is kind of hard, but we know that log 2, 8. 8 is 2 to the power how much? 8 is 2 to the power 3. Therefore, you can write this answer as 3. So you can simply write 1 over 3. So if you just do it, 8 to the power 1 over 3 is 2. So the answer is correct. That is the situation where we have to understand about this logarithmic rule, right? Okay. Let's go into the another rule. The next rule is log AB. This is called tritary base rule. That is, you can write log AB using a third rule, third base. You can write this is log XB, B at top, divide by log A at bottom, right? Now from an example, let's try to understand how to get these figures, right? For example, if you want to get this kind of situation, if I want to get log, we will get 8, I'll get 32. We know that 8 to the power 1 is how much? 8. 8 to the power 2 is 64, but 32 is an intermediate value. So that problem is there. Therefore, we cannot get any power of 8 as 32, not an integer power. Therefore, it's kind of hard for us to understand. For this, but you can understand that 32 and 8 both are powers of 2. Simply then you can write this fact in this way. Log 232 divide by log 2 8. I can get in this format. Log 232 is how much? 32 is 2 to the power how much? Shaina, what is the power of a logarithm of 32 to 2? What is this answer? What is the answer for this bit of it? 32 is which power of 2? 2 to the power 1 is 2. 2 to the power 2 is 4, 8, 16, 32. That is 2 to the power 5. So here the answer is 5. 8 is 2 to the power, we already work out 3. So the answer is 5 over 3. If you want to check, you just check 8 to the power 5 over 3 and see whether you will obtain this answer 32. Hope you have understood this context, right? Okay. Initially, I just make it a little bit of small, then you can see the entire rules at once. A little bit smaller. Yeah. These are the rules where we need to know, right? Okay. I just use a different color, then can it be highlighted over here. This one, these are the rules and other ones are the examples. These are the things where we need to know. Okay. Yeah, right. Okay, now let's basically come up with the question and let's try to understand what kind of situation they were questioning about from this theory. Right. Then, yeah, these are the rules what they have mentioned here. Then they mention write as a single logarithm, log 3, 6 and log 3, 7. Log 3, 6 and log 3, 7 plus log 3, 7. They need to write it as a single logarithm, not to simplify. They just want to get log 3, 6 plus log 3, 7. Then is the addition you can write this is log 3, 6 into 7. That is turn up to log 342. That is the answer for that, right? Okay, let's go to another example. The second example is log 3, 15 minus log 3, 2. Sorry. Log 2, 15, log 2, 3. Log 2, 15 minus log 2, 3. This one you can say log 2, 15 divided by 3. That is turn up to log 2, 5. So later on we learn how to get these answers. For the moment, just keep it as it is. They need to write it as a single logarithmic term. Right. 2 log 3, 3 log 2. 2 log 3 plus 3 log 2. So this is basis given is 5. Then put it here, initial I can take this 2 in and write it as a power. Log 5, 3 to the power 5 plus this one you can write log 5, 2 to the power I can bring this 3 down and you can write it with it. So this answer become then log 5, 3 to the power 5 times of 2 to the power 3 and you can obtain this answer, right? Right. Then that is how you need to get it. So after that, you can get this answer 3 to the power 5 to 2 to the power 3 and you can write log 5 of that amount. Right. It's a quite big amount, so you can just work out. I think the answer is here. 3 to the power 2, yeah, 9 and 8, and 2, just 1 second, 3 to the power 2. Sorry, here I did made a mistake. This is 3 to the power 2. This is 3 to the power 5. This is 3 to the power 2, right? So 3 to the power 2. So 3 to the power 2 is 3 to the power 2 is 9, 72, sir. That's correct. 72. Then the next fact is just like this, but if they mention just like a situation, sorry, log 10 3, 4 log 10 half, log 10 3 plus 4 log 10 half. Yeah, 4 log 10 half minus, it's minus. Sorry, this is minus, but it's not plus, right? Then what you can get here is, yeah. So initially what you can get here is I can take this 4 in. So now to log 10 3 minus, this is log 10. You can write half to the power 4. Then this is turn up to log 10 3, minus means you can say divide by, minus means division. Half to the power 4 is 1 over 16. 1 over 16. So this is turn up to log 10 3 into 16 over 1. Right. Then you can say this is turn up to log 10 48 is the final answer for that. That's a way of getting this kind of an answer. Okay. Right. Then yes. Then they might give a question like this, Pute. Right. They mention write in terms of log x, log ay, and log az. Right. The first example they have given is this is given log a x to the power 2 y z to the power 3. Right. Initially, what you can write, these multiplications, you can write it as addition. Log a x to the power 2 plus log a y plus log a z to the power 3. Now you can write these powers out and you can write this answer as 2 log a x plus log a y plus 3 times of log a z. That's the answer for that. That's a way of getting this right. Part B. If you work at part B, log a x over y cube. Log a x over y cube. Initially, I can write this division as a subtraction. Log a x minus log a y cube. Because it's a division, you can write it as a subtraction. Subtraction write as a division. Division you can write as a subtraction. Then you can take this power out and you can write log ax minus 3 times of log ay. So what you need to do is before you do this, just make a bring this formula sheet into a one piece of paper and keep it closer to you. With that gives you some kind of extra help for you to understand how we did this question today. So that is the best option of doing it. But for the first time when you're looking at it, you feel like kind of hard, but with the time you'd be familiar with that. So that is turned up to log a x square root of y divided by z, right? Initially, I can say that these two multiplication, you can write it as addition. Log ax plus log a square root of y. I will write square root of y is a power half. Square root of y can write y to power half. This division you can write it as a subtraction, log a z. Then the next simplification is you can keep this power out and you can write it. Log ax, you can write this power out and you can write 1 over 2 log a y minus log a z. That's how it comes with it. Then d. D is, this is little bit of another few more simplifications are there in this example. Log a x over a to the power 4. Now, how do you get this right? Okay, so you can write this is log a x. This division you can write it as a subtraction. Log a to the power 4. Right. Then what you can get here is you can bring this 4 out. Log ax minus 4 times of log aa. What is the log aa value is how much? A is a to the power 1 because this is the same base and same power. So you can write this one as log ax minus 4 because this is log aa is 1. So if I just, for example, if you get this thing, so if I write log 2, what is the value? It's 1. Log 4, it's 1. Log 100, that one also 1 because 100 is 100 to the power 1. Yeah, like that you can come. So that's a theory where we need to understand about this kind of a situation, right? Okay. Right, like that you can get this answer. Then the next extension is they ask you to question somewhere like this, Pute. They can ask you to solve a one easy equation. Solve log 10 4 plus 2 log 10x is equals to 2. Let's see how to do this question. Initially, I can bring this 2 in and write it as a power. I'm writing all the steps, but with the time being, when you're familiar, you can get these answers very easily. Log 10 x to the power 2 equals to 2. What I did was I just take this 2 input. Then this, because of this addition, I can write this one as log 10 4x squared is equals to 2. So addition means you can write as a multiplication. Then we know that there's a rule. We already learned log a x is equals to k means we know that x is equals to a to the power k. From the yesterday theory we know. Then you can write 4x squared is equals to 10 to the power 2. So you can write 4x squared is equals to 100, x squared is equals to 25, x is equals to 5. That's the answer where we need to get it. That's the way of getting this, right? Okay. We will go to a few more examples just like this. They might give you this kind of question. Log a x plus 1 minus log a x minus 5 is equals to 2. So initially we can solve this logarithmic function. So this bit. So you can write this is log a x plus 1. This minus you can write it as a division. X minus 5 is equals to 2. So this is not a, this is 3. I just made a mistake. This is not base, is not a, base is 3. Other than that, you cannot get, you have to get so as an expression only. So this is, you can say, so this is turned up to 3. Then you can write x plus 1 over x minus 5 is equal to how much? 3 to the power 2. Right. Then if you simplify this, you can get x plus 1 9 times of this is turned up to x minus 5. So x plus 1 equals to 9x minus 45. Then you can say 9x minus x equals to 1 plus 45. 9x minus x is 8x is equals to 46. X is equals to, sorry, I just, yeah, have I made any mistake? Yes, that can't help. So you can say it's 46 divided by 8, or you can write 23 divided by 4 is equals to x. That's a way of getting this answer. Right. Let's go to another question and try to understand. If you have a question like this, log 2x plus 1 it's equals to, log 2 x plus 1 is equals, sorry, plus 1. Then for this kind of situations, what you need to do is you have to bring this all logarithm terms to one side and simplify. Log 2, 2x plus 1 minus log 2, x plus 1 is equals to 1. There is nothing here. Right. Then you can write this way. This subtraction you can write this is log 2, 2x plus 1 over x plus 1 is equals to 1. Then you can write 2x plus 1 over x plus 1 is equals to 2 to the power 1. Then you can say 2x, I'll just make it as 2. Other than that, you don't get a good answer. But other than that, you get some kind of a confused answer. So this is not 1. I have to take it as something else. Just like history, because other than that, you don't get an answer. Then you carry 2 to the power 3. 2x plus 1 is equals to 8 times of x plus 1. Then you get 8x plus 8 is equals to 2x plus 1. So if you brought this one to other side, 8x minus 2x equals to 1 minus 8. Therefore, 6x equals to minus 7. Therefore, x become minus 7 over 6. That's the answer value you need to get. Yeah. Right. Let's go to another example. Yes. They might give you 2 times of log 3 x plus 1 divided by, sorry, minus log 3 2x plus 1 is equals to 1. Then initially what you can write here is you can say this is log 3. This you can take this 2 in as a power, x plus 1 to the power 2. This subtraction you can write it as a division. 2x plus 1 is equals to 1. Then you can say x plus 1 to the power 2 over 2x plus 1 is equals to how much? 3 to the power 1. So I just wrote here because like again if I just write it same thing, log a x equals to k means you know that x equals to a to the power k. Same thing I just did over here. So then you can say expand it with x squared plus 2x plus 1 is equals to 3 times of, I can cross multiply with a turn up to 2x plus 1. I just brought this x to this side. Then you can write this is x squared plus 2x plus 1 is equals to 6x minus, sorry, plus 3. So this is turned up to x squared plus 2x plus 1 minus 6x minus 3 is equals to 0. With that you can write x squared minus 4x minus 2 is equals to 0. With that you can get the answer. X equals to minus minus 4 is plus 4 plus or minus b squared minus 4 squared minus 4a is 1, c is minus 2 divided by 2a. So with that you can say x is equals to 4 plus or minus square root of 16. 16 plus 8 is 24 divided by 2. So this is turned up to 4 plus or minus root 24. Root 24 you can write, it's 4 into 6, 2 root 6 divided by 2. So you get the answer x equals to, if you divide by 2, 2 plus root 6, other one is 2 minus root 6. That is the answer for that. That's a way of getting this answer. Right, okay. That's a way of understanding this kind of situations, right? Let's see what kind of examples they ask further. They might ask you to solve. Okay, solve log 240 minus log 2 5. So see, straightforward, if you get this answer, you cannot get any solution. This is not the equation just to solve this. So you can write this is log 2 40 divided by 5 is how much? It's turn up to log 2 8. What is the log 2 8 value? Log 2 8 is 3. 8 is 2 to the power 3. Right, that kind of questions you can get it. 2 log 10 2 minus log 10 5 plus log 10 8. So this is turned up to this way. Log 10 2 to the power 2 minus log 10. You can multiply these two, put 5 into 8. So it's turned up to log 10 4 divided by 5 into 4 is 80. That is turned up to log 10 1 over 10. 1 over 10 is how much? So this turn up to log 10 10 to the power minus 1. So final answer is minus 1. That's a way of getting this kind of a question. Right. Then another extensions. They might give a question like this. They have given log 3 x plus 1 equals to 1 plus 2 log 3 x minus 1. They ask us to show that 3x squared minus 7x plus 2 is equals to 0. So simply this is just a simplifying of this logarithm and form into a quadratic format. So that means you can say log 3x plus 1. You can take this whole log term to other side. Minus 2 log 3 x minus 1 is equals to 1. Then you can write this one as log 3 x plus 1, because it's minus, it's a division. You can take this 2 in as right as a power. It's minus 1 power 2 equals to 1. I think you can understand how it came. Right. Then you can write this is x plus 1 over x minus 1 squared is equals to 3 to the power 1. Then you can write this way. X plus 1 is equals to 3 to the power 1 is 3 times of x minus 1 squared. So if you expand this, you get x plus 1 is equals to 3 times of 3x squared minus 6x plus 3. If you brought all the terms to one side, turn up into 3x squared minus 7x plus 2. That's it. So from there you can get this answer. So these are the extensions where they ask from this kind of a question. Right. Okay. Yes, sometimes we might come across this kind of situations as well. They need to show so they might give you a plus b is equals to 2. Then they give us log 3a plus log 3b is equals to 1. They ask us to solve these simultaneous equations. So what you can simply do is you can simplify this logarithmic term. Then you can say from 2. You can write log 3ab is equals to 1. From here you can write ab is equals to 3 to the power 1. That is ab is equals to 3. Now you can say, this is, I'll take this one as for third equation today. From 1 and 3. We can write from here, from 3 I can take a is equals to, from this way I can write a equals to 3 over b. Then you can write this is, instead of a you can write 3 over b plus b is equals to 2. Then multiply everything with b. Right, 3 plus b squared plus 2b. What I did was, I just substitute, because I need to solve this for two simultaneous equations. Then, so what can I do is I just subject a from here and substitute into this. Right. Then you get this one. To simplify this, you have to remove this denominator b. So for that, I just multiply everything with b. Then you form a quadratic equation. Minus 2b plus 3 is equals to 0. Right. Then you can say this is, I don't think that for this one you get some kind of solutions, right? Because This has turned up into, yeah, 4, 4. Yeah, no, it's not. So you have to make this one as a different number. From this one, it won't come because one, if you get one, you don't get a reasonable solution for this. I just make a little bit of change. It's equals to 2. 2, 3 to the power 2, it's 9. 9 over b. So you can put this is 9 over b. 9 over b squared plus 2b plus, no, I don't think 9 also work, because then the values become so higher. Just we'll scrap this question because because this one does not give any solution for the, so just this kind of situation. So you can say this kind of thing. You can write this one. Yeah. A plus b is equals to 13 log 6a plus log 6b is equals to 2. This is my first equation, my second equation. Then you can write from 2, you can write this is log 6ab. If you multiply this one equals to 2. So you can write ab is equals to 6 to the power 2. Then you can write AB is equals to 36. This is my third equation. Then I'll get the first equation. A plus B equals to 13, my first equation. AB equals to 36 is my second equation. Then you have to solve these two as simultaneous equation. You can use a method of substitution. From 2, you can write A is equals to 36 over B. Then I can substitute here, sub in 1. And you can write A, instead of A, you can write 36 over B plus B is equals to 13. Then multiply everything with B with it. 36 plus B squared equals to 13B. Then B squared plus minus 13B plus 36 is equals to 0. If you simplify this, you can, yeah, 13b. So you can write this is 12 into 3, 18 into 2. So anyway, we need to get some solution for this. 636. So yeah. Then you can get the answer for b. So you can write b is equal to plus or minus, sorry, minus 13 plus or minus b squared minus 4a. A is 1. C is 36 divided by 2a. 2 into 1. So from here you can get the answer B is equals to 13 plus or minus the square root of 169 minus 72 144 divided by 2. So this is turned up to B is equals to 13 plus or minus 169 minus 144 is 25. It's 5 divided by 2. From here you can get B equals to 13 plus 5 is 18 divided by 2 is 9. Other one is B is equals to 13 minus 5 is 8. 8 minus 8 divided by 2 is 4. Then you can substitute into this, any of this equation, you can obtain the answer for A. From here, A is equals to 36 over 9 is equals to 4. B is equals to 9. These are the solutions.